Let's hear it, Grace.
It's time for Maths with Mr. Thomas.
Yes, it is. Here we go. Chapter 2, lesson number 3. We're moving on to adding and subtracting fractions. Woo! So let's say we have these two fractions here. 2 quarters add 1 quarter, and it's represented by these diagrams here. If you add them together, well, going by the diagrams, you can easily see that that is what you would end up with if you just put them together, if you just add them. And what would that give you if you have 2 quarters and you add on one other quarter? Perfect, that would give you 3 quarters. You can see that because the denominator, the number at the bottom, the 4, is the same, it's dead easy to add these fractions. All you're doing is you're saying how many of the quarters you have. However, let's mix this up. Let's say we have 2/9, which would look something like that, and we have 3/7, which would look something like this. If we add them together, well, again, if you go by the diagrams, you would end up with something that looks like that, because you're just going to draw one, then the other, you're putting them together. But the fraction, what fraction would that be? Does anybody know? There's a lot of confused faces, and I don't blame you. I have no idea what that would be. The reason is because the denominator is not the same. So when the denominators are not the same, it's more difficult to add them. You can't just say, oh, I've got this many quarters because I'm adding quarters to quarters, or I'm adding fifths to fifths. This time, because you're adding 7ths to 9ths, it's more confusing. And what you need to do is you need to use your knowledge of equivalent fractions to first of all find what is known as the lowest common denominator. So let's work through a few examples finding the lowest common denominator. Example 1, work out 1 quarter, add 2/9. Once again, you can see the denominator, the number at the bottom, well, the numbers are not the same. And one of them you've got quarters, another one you've got 9ths, they're not equal. So you need to find the lowest common denominator of 4 and 9. How do you go about doing that? What would you do, Jake? Perfect. What you can do is you could think about all of the multiples of 4. So start off with your 4 times table, 4, 8, 12, 16, and so on. And you can think about all the multiples of 9, with 9, 18, 27, blah, 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 blah. And what you really want to do is you want to find the lowest, so the smallest, and common means something they have in common. If you and I have a love of badminton in common, well, it's something that we both like. So it's going to be something that's in both sets, in the 4 times table and the 9 times table, and it's the lowest number. So what's the lowest number that's in the 4 times table and in the 9 times table? Well, let's go with the 9 first of all. So you can see with the 9 times table, there's a 9 in it, but there's no 9 in here. There's an 18 here, but there's no 18 in here in the 4 times table. There's a 27, but there's no 27 in the 4 times table. There's a 36 here, and dun dun dun, there is a 36 in the 4 times table. So that is a number that they have in common. It is the lowest number that they have in common, so it's known as the lowest common denominator. Boop, boop, boop. So what we want to do is we want to change each fraction to write them both as something over 36. The way that we do this is by using our knowledge of, as I said in the last page, equivalent fractions. So what we're doing is we're wanting to change the 4 into 36. And to change the 4 to 36, we have to think, what do we multiply by? Perfect, you got it. So 4 times 9 will give you 36, so we're multiplying by 9. And because we've multiplied the denominator by 9, we also have to multiply the numerator by 9 as well. So we do 1 times 9. And 1 times 9 is 9. And taking the 2/9 now, again, we want to write that as something over 36. So again, we're thinking, how do we go from 9 to 36? What do you times by? 9 times 4, good. 9 times 4 would give you 36. So because you're multiplying the denominator by 4, you also multiply the numerator by 4 as well. So 2 times 4 will give you 8. So 2/9 is the same as 8/36. Because the denominator is the same now, woo, you can add the numerators. So we've got 9/36, and then we add on 8/36. So really, it's how many 36 have you got? Well, you've got 9 of them, you're adding 8 of them, which means you've now got 17/36. Woo! And as it says here, hello! Make sure you always check to see if you can simplify your answer. With 17 and 36, there's no times table that they both divide by, apart from 1, but then you'd be left with 17 and 36. So we just leave it as that. That is our final answer. Example 2, work out 1/2 plus 3/5. You can see again the denominator is not the same. We've got a 2 and we've got a 5. Dun, dun, dun! So as it says here, we have to find the lowest common denominator of 2 and 5. So to do that, once again, you are thinking about your 2 times table, which I'll put over here, and you are thinking about your 5 times table. You want to find the lowest number that appears in both sets, so the lowest number that is in here and in here. And what's the smallest number that is in both of them? Perfect. You can see the smallest number would be 10. There's a 10 there and there is a 10 there. Note there is also a 20. There's a 20 there and a 20 there. Would you use the 20? No. Why not? You want the lowest. You do indeed, yes, you want the lowest, so you wouldn't use the 20, you would use the 10. Which means we can change 1/2 to something over 10, and we can change the 3/5 to something over 10 as well. So the denominator would then be the same. Looking at the denominator, we have changed that from a 2 to a 10. Bam, bam, bam. So, what did we multiply by? 2 times what gives you 10? 5. Well done. So, because we've just multiplied the denominator by 5, we have to multiply the numerator by 5 as well. So 1 times 5 is obviously 5. On the right hand side, we've changed the 5 to a 10. How do we change the 5 to a 10? What did we multiply by? 2. Brilliant. Well done. 5 times 2 would give you 10. So you do the same thing with the numerator. So you do the 3 times by 2, which gives you 6. From there, we've got so many tenths and so many tenths. So we can work out how many tenths we have by adding the numerators together. So 5 add 6 is 11. You got it. So we've got 11 tenths. Would we leave it as 11 tenths? No. No, we wouldn't, because this is an improper fraction. And when you're left with an improper fraction, you're best to write it as a mixed number. So to go from the 11 tenths to the mixed number, all you do is you do 11 divided by 10. Think how many 10s are in 11? Well, that's 1, so that's your whole number. And what would your remainder be? Brilliant, your remainder would be 1. And because we're working with tenths, we just keep it as tenths. If you're unsure about this, look back to the last lesson. There are quite a few examples on that. But that would be your final answer, the 1 and 1/10. Example 3, we've got 6/7 and we're taking away 5/6. Once again, you can see the denominators are not equal. We've got a 7 and we've got a 6. Woo! So what we need to do is we need to think about the lowest common denominator. And to do that, think about all the entries in the 7 times table. So 7, 14, 21, 28, 35 and so on. And think about all the entries in the 6 times table. Remember, we are looking for the numbers that they have in common. So we're looking for numbers that appear in this set and in this set. And it's the lowest one that we want. What is the smallest number that then appears here and in here? Shout it out in 3, 2, 1. Well done, you got it. It is 42. There's a 42 there and there's a 42 there. There is no number that is lower that they both have. So we're changing the 6/7 to something over 42 and we're changing the 5/6 to something over 42. We need to work out what we are multiplying 7 by to get to 42. So 7 times what is 42? Brilliant, you are multiplying by 6. So because we've just multiplied the denominator by 6, we multiply the numerator by 6 as well. So 6 times 6 gives you 36. Well done, Hattie. And we've gone from 6 to 42. So how do we do that? What are we multiplying by? 7. We are multiplying by 7. So you also multiply the numerator by 7. So 5 times 7 gives you 35. We've got 36 over 42. We're taking away 35 over 42. So it's how many 42ths we have left. So 36 take away 35 would give you 1, and that would be over the 42. The denominator would just stay the same. So it would be 1 over 42 for our answer. Woo! Example 4, work out 1.5 take away 3/8. So you'll notice this example is slightly different because we have this mixed number to begin with. Ooh! What do you think we do when we get a mixed number, Marley? Perfect, you change it to a improper fraction. So, changing 1.5 to an improper fraction, Marley, would give you, good, 3 over 2. You do the 1 times 2, which is 2, add on the numerator, so add on the 1, which gives you 3, and keep the denominator as is. So 1 times 2, add 1, and then keep it over 2. The 3/8 Just keep 3/8 as 3/8. Now we can subtract these fractions. However, the denominators are once again not equal. So we need to find the lowest common denominator. To do that, once again, think about the 2 times table. Think about the 8 times table and look for the lowest common denominator. Well, you can see the numbers they have in common. There's a 16 in the 2 times table and there's a 16 in the 8 times table. But remember, you are wanting the lowest common denominator. So what is the lowest number that appears in both sets? Brilliant, well done. There is an 8 here and there is an 8 here as well. So that would be the lowest, meaning you definitely would not use 16. Make sure you always go for the lowest. So we want to change the 3/2 to something over 8, and we really want to keep the 3/8 as 3/8. We're not changing that. That's already over 8, and that's what we're wanting. So we just keep that as is. However, with the 2, we are changing the 2 to an 8. So what do we multiply 2 by to get to 8? That's just 4, brilliant. So you multiply the numerator as well. So you do the 3 times the 4, which will give you 12. So you know 3/2 is the same as 12/8. Now we have 12/8, take away 3/8. Because we've got 8s and 8s, we're just really saying how many 8s we have. So we've got 12 of them, we're taking away 3 of them, which means we're left with 9 8s. Once again, you'll notice that we have an improper fraction here. So what do? Brilliant, we rewrite it as a mixed number. So if you do 9 divided by 8, well, that would give you 1 whole, and then you would have a remainder of 1. So the remainder of 1 becomes the numerator, and the denominator will just stay as 8. Well done, you've got it. Fantastic. Woo! Example 5. Work out 2 4/5 plus 3 3/7. I'm going to show you 2 methods for doing this. You can choose whichever one you like. As long as you show you're working and you get the right answer, it makes no difference whatsoever. First method I'm going to use is similar to what we were doing in the last example. So, first of all, because we've got 2 4/5 and 3 3/7, well, you can see there are 2 mixed numbers. So I'm going to start off by changing the mixed numbers to improper fractions. So, 2 times 5 gives me 10. Add on 4 gives me 14, so that would be the same as 14/5. With the 3 3/7, I do 3 times 7, which is 21. Add on the 3 is 24, and I just keep the denominator, keep the 7ths as it is. So rewriting these as improper fractions, I get 14/5 and 24/7. Now, I want to add them. But you can see the denominators are not equal. But so you have to get the same denominator. So think about the 5 times table and the 7 times table. In all the other examples, I had the times tables written out. This time, can you work it out? What is the smallest number that appears in the 5 and the 7 times table? Erin, you look like you know. 35. It is 35, yes. So we can write the 14/5 as something over 35, and we can write the 24/7 as something over 35. Now what you want to do is you want to think, how do you go from the 5 to 35? What are you multiplying by? Well, it's 5 times 7 that will give you 35. So because we're multiplying the denominator by 7, you also have to multiply the numerator by 7. So you do 14 times 7, which gives you 98. On the right hand side, we've got 24/7 would become something over 35. So now you think 7 times what gives you 35, and you are multiplying by 5. So multiply the numerator as well by 5. So 24 times 5, it does give you 120. Good. So because you've got something over 35 and something over 35, well, you know your answer will be something over 35, and all you do is just add the numerator. So do 98, add on 120, which gives you 218 over 35. If you then work out how many 35s are in 218, we'll start working up in 35. So do 35 add 35, which will then be 70. So that'll be 2 of them. Add on again, it should be 105. Keep on going up, and you'll find that you will get 6 whole parts. So it'll be 6, and you will have a remainder of 8. So you'd have 6 and 8 over 35. Now that is the first method for doing that, and you can use that if you want. However, there might be a slightly easier way of doing that. Because you can see you've got 2 mixed numbers, it means you're going to get, when you write it as an improper fraction, you're going to get bigger numbers on the top, which means when you're multiplying by the 7 and the 5, you end up with 98 and 120. It's big numbers that you end up with. So here's another way. The 2 4/5 This is just an alternative method, so you can use this if you want, or if you're fine with that first method, use that. But the 2 and 4/5, that means you've got 2 whole parts and you've also got 4/5. With the 3 and 3/7, it means you've got 3 whole parts, and again you've got the 3/7 left over. So you could rewrite that as, let me get rid of that, so you could rewrite that as the 2 and the 3, and you're also left with a 4/5, and you're left with a 3/7. So we're just breaking this up. We're taking the whole part, which is a 2, the whole part, which is a 3, and then the fractions, we've got 4/5 and a 3/7. From there, because you've got the 2 and the 3, well, we know 2 add 3 is 5, so we just rewrite that as 5. And now all we have to do is just add these 2 fractions together. So the 4/5 and the 3/7. To do that, once again, you're thinking of the lowest common denominator for 5 and 7. And if you think about the 5 times table and the 7 times table, well, the smallest number that appears in them both is going to be 35. So to go from, let me get rid of that, to go from 5 to 35, you times them by 7, so do the 4 times 7, which gives you 28. To go from 7 to 35, well, you're multiplying that by 5, so you do the 3 times 5 as well, which is 15. It's just the same as we did in the other examples. We're changing the 5 to 35. How do we do it? We times by 7, so times the 4 by 7 as well. We're changing the 7 note to 35, so how do you do that? You times by 5, so you times the 3 by 5 as well. Because of that, you've now got 5 plus, 5's not going to change, so you want to see how many somethings over 35 you would have. So we've got 28 over 35 and 15 over 35. Because the denominators are the same, you can add the numerators, so 28 add on 15, which will give you 43, and the denominator stays as it is. Because you've got 43 over 35, that is an improper fraction. So what you do next is you would write that as a mixed number. So we've got 5 plus, and then you think, what's 43 divided by 35? Well, how many 35s go into 43? It is just 1, and you would have a remainder of 8. Good, so it's going to be 8 over 35. And then from there, you've got 5 whole parts, you've got another 1 whole part, so overall you would have 6 whole parts, and we've still got this fraction of 8 over 35. And again, you can see that as the answer. Pick whichever method you like to do this, as long as you practice it and you're okay with that method. Example 6, work out 3.5 plus 2/3, take away 4/5. So for this one, once again, I'm going to go down the route of changing to an improper fraction. So 3.5, if I write that as an improper fraction, what would that be? Brilliant, that would be 7 over 2, because you do 3 times 2, which is 6, add on 1, which is 7, so it's 7 over 2. Plus, keep the 3 over 2 just as it is, and keep the 4/5 just as it is. So we get 7 over 2 plus 2/3, take away 4/5. Now all we need is the lowest common denominator of 2, 3 and 5, and if I can squeeze these in just about, that is all the entries in the 2 times table, or some of them anyway. That is the entries in the 3 times table, and that's the entries in the 5 times table. You need to think about what the smallest number would be that appears in all the 2, the 3 and the 5 times tables. And the smallest entry would be, you've got it, yeah, it's 30. 30 is in the 5 times table, 30 is in the 3 times table, and 30 is in the 2 times table. There is no smaller number that appears in all of these times tables. So we're wanting to change the 7 over 2 to something over 30. The same with the 2/3, change it to something over 30. And the same with the 4/5, change it to something over 30. So to do that, take the 7 over 2. First of all, we are going from 2 to 30. What do you multiply 2 by to get to 30? Brilliant, you're multiplying by 15. So do the same with the numerator. So do 7 times 15, which gives you 105. Next fraction, you've got the 2/3. We're wanting to change the 3 to a 30. So what do you multiply by there? Good, you're multiplying by 10. So because you're multiplying by 10, you also multiply the 2 by 10 as well. So 2 times 10 just gives you 20. And finally, you're going from 5 to 30. What do you multiply by there? So 5 times 6 will give you 30. Because you're multiplying by 6, you have to remember to multiply the numerator by 6 as well. So 4 times 6 gives you 24. After that, because you've got so many 30ths, you've got 105 30ths, and then you've got 20 30ths, and you're taking away 24 30ths, you know your answer is going to be something over 30. And all you would do is do 105 add on 20, and then take away 24. And what would that give you, Derek? Brilliant, that does give you 101. So you end up with 101 over 30. Would you leave your answer as that? Camille, you're shaking your head. Why not? Good, because it's an improper fraction. If you get an improper fraction, rewrite it as a mixed number. So, 101 divided by 30. How many 30s are in 101? 3! Brilliant. So that is going to be your whole number part. And what would the remainder be? Brilliant. You would have a remainder of 11. And because you're working with 30, keep the denominator as 30. And that is your final answer. Woo! Final example, example 7. From a 12-metre cable, an engineer cut off a piece that was 5 3/7 metres long. What is the length of cable remaining? Bum, bum, bum. So we know for this one, we have a 12-metre cable. So we've got the 12, and we're wanting to cut off. We're cutting the 5 3/7, so that is what we are taking away. There are different ways to do this, so if you're doing it a different way, that's absolutely fine, as long as you are still getting the right answer and you're showing what you're doing. So for this, I've got the 12 and I'm taking away the 5 3/7. What you could always do with this one is you could think, right, well, I've got the 12 metres and I know I'm at least cutting off the 5 and a bit. So you know if you do the 12 take away 5, well, that's going to give you 7. So cutting off the 5 metres would give you 7 metres. But you're also taking away that 3/7 as well. So we've got the 7 metres remaining if you just cut off the 5, but we're also taking away that 3/7. So you could rewrite that as 7 take away 3/7. With this, we are wanting to subtract a fraction, and when you're subtracting a fraction from a whole number, well, it's far easier to subtract a fraction from a fraction. So you want to imagine the 7 as a fraction. And to do that just now, as it stands, 7 you could imagine as a fraction. Just think of it as 7 divided by something, and to give you 7, and 7 divided by what gives you 7? Well, it's just 7 divided by 1. So you can rewrite 7 as 7 over 1, or 7 divided by 1, because that's just 7. So now what we've got is something over 1 and something over 7. So once again, we need to get the lowest common denominator. So think about the 1 times table. So 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 blah. Think about your 7 times table. So 7, 14, 21, and so on. What's the smallest number that appears in them both? 7! Perfect. Well done. So 7 is just what the lowest common denominator is going to be. With 3/7, well, that's already 7, so we can just keep that as 3/7. However, what we've done here is we've changed the 1 to a 7. How did we do that? Well, we did 1 times what is 7? 7! Brilliant, it's 1 times 7. So you also have to do that with the numerator as well. So you do 7 times 7, which would give you 49. So we've got 49 over 7, take away 3 over 7. Some people are probably wondering, could you just go to the 49 over 7? Because you know 49 divided by 7 is 7, so you could rewrite the 7 as 49 over 7. And yes, that's absolutely fine. Again, there are quite a few different methods for answering this question. What I'm doing is I'm getting the same denominator, so I've got so many 7ths, I'm taking away so many 7ths. Because the denominator is the same, woo! You can just subtract the numerators. So you would have so many 7ths left over. And how many 7ths would that be? 46! Well done, because you're doing 49, take away 3, which is 46. So you'd have 46 7ths. Once again, you end up with an improper fraction, and when you get that, you're best to rewrite it as a mixed number. Again, look back at the previous lesson for quite a few examples on that. We have 46 over 7, so now what you do is you do 46 divided by 7, which goes how many times? 6! Brilliant, well done. So that is going to be the whole number part, and you would have a remainder of... Brilliant, well done, you have a remainder of 4. And because we're working with 7ths, we just keep the 7ths just as they are, keep the denominator just the same. So you've got 6 4/7 meters, and that would be your final answer. Look back at any of the examples again, just make sure that you are okay with them. If you're not, as I said, just look back. But if you're okay with that, try some of these questions in the TJ Level F book. There are loads of other books with adding and subtracting fractions. You'll find loads of pages online as well, loads of answers. Just try some questions, see how you get on, check you are getting your answers correct. Best of luck, and well done. Woo! Yeah.